Today starts our Unit 5, which will be on weathering and erosion. Today we're really just going to look at weathering. So weathering is the breakdown of rocks. We already looked at this a little bit in Unit 4 when we were talking about our rock cycle. We talked about how weathering breaks rocks up into sediment. Well, that's what we're going to be looking at today. How does this weathering occur? What are the different types of weathering? And there's really two main types, mechanical and chemical. So just in a minute, we'll look at the two differences of that. We're going to talk about erosion a little bit differently, in just a little bit, but I wanted to point this out because a lot of people have heard about erosion from middle school and they get the term weathering and erosion mixed up. Weathering breaks things down. Erosion moves it around. Okay, so weathering breaks it down. Erosion moves it around. And again, we will talk about erosion on another day, but I just wanted to point that out since I know it's something most of you have heard before. Make sure you understand that they are two different things. So let's look at mechanical weathering. Mechanical weathering is also called physical weathering. And the reason it's called physical weathering is because mechanical weathering simply produces a physical change in the rock. Whenever you have a physical change, that simply means that you are not changing the composition. So it does not change the rock's composition. Composition means whatever it's made up of. So for example, if I get a piece of paper and I tear that piece of paper in half, I have not changed what that paper is made out of. It's still paper on each side. So that was simply a physical change, or a mechanical change. If I burn the piece of paper, then it is now made of something new, and that is what we would call a chemical change in the paper. So there's 4 ways that your mechanical weathering can happen. That's frost wedging, unloading, biological activity, and abrasion. And we're just about to look at each of those individually. But for the main thing, just know it is simply a physical change, which means no change in the composition of the rock. So let's take a look at frost wedging. Another term for frost wedging would be ice wedging because frost is ice. And so what happens when you have frost wedging is there's a little crack in the rock, kind of like what you see here, and water goes down into the crack of that rock. Now, when water freezes, it expands. I don't know if any of you have ever put a water bottle in the freezer and maybe the lid was on pretty tight, but when you put that water bottle in the freezer, if you leave it, then sometimes it will actually bust that water bottle open because the water expands and it needs room to grow into. So that's what your water's doing to the rocks. It goes down into that crack, it freezes, and then it starts to slowly wedge the rock apart little by little until it's broken up into pieces. Another term that you'll hear with this is called freeze-thaw cycles. So freeze, thaw, cycle. And the reason they say this freeze-thaw cycle is because think about like when we have snow. It will be really cold, and so it will freeze at night, and then maybe by noon the next day, the weather will have warmed up, and so that ice melts back into water. Well, then at night, it refreezes. Next day, it melts. At night, it freezes. And so you have this freeze-thaw cycle going on, and if you keep having that occur to the rocks, then ice wedging occurs again and again and again each night, and so that's when you're really going to see a lot of weathering for this. We see a lot of ice wedging in what creates our potholes. So next time your parents hit a pothole in the car, then you can blame that probably on some frost wedging that weekend up the road. Our next one is unloading. Some of you have some really heavy book bags, or at least you've probably had some heavy book bags in the past if you're an all-virtual learner. And when you get home and you take that book bag off, it's just a weight lifted off your shoulder and it just releases all that pressure. Well, that's what unloading is. Unloading is when you have a dome of rock, so dome looking kind of like this, and I've got a picture on the next slide. But that dome of rock, it's typically igneous rock, and it has pressure that is pushing up on it. So it has a force that's pushing up, and that causes pressure to cause the very outer layer of this dome of rock to crack and pop off. When that layer cracks and pops off, we call that exfoliation. So if you exfoliate your face, then you typically are using like a scrubbing type of face wash, and it's just taking that outer layer of skin cells off. That's what's going on here. When you exfoliate the rock, the outer layer of the rock is coming off. It's popping off. But the reason that's occurring is because of pressure. And I'll show you this on another side, the actual dome. Now, this is not a volcano. I want to point that out. This is igneous rock, but these are not active volcanoes that this is occurring in. So here's a picture of a dome of igneous rock. So you can see it's like a mountain shape, but there's pressure pushing up on this rock from below the surface. And as you can see, these slabs of rock, like this one right here and this one right here, those slabs of rock are popping and peeling off. It's like the rock is shedding its skin, kind of like a snake. And that would be the exfoliation part that occurs in unloading. I do recommend you watch this video. So if you go back to the page on Canvas with the YouTube link that you click to get to this, there will be an exfoliation link. If you go to that video link, then you will be able to see in real life what exfoliation looks like. This is actually something that scientists had never seen before. And there's this geologist standing on a mountain, and the rocks were just popping, literally popping from the ground up. And so they got it on film, and that was the first time that had ever been seen. So I do recommend that you go back and you watch that so you can just see it and visualize it, and it'll make a little bit more sense to you. The next type of weathering that we have is biological activity. Now, hopefully you remember from Unit 1, but bio means life. So this is weathering caused by a living thing. So this more than likely is going to be a plant. Yes, you could have an animal cause a rock to break, but you don't go outside that often and see squirrels who are pushing or throwing rocks against sidewalks and cracking them open. Okay, that's not very normal. So this is mainly going to be your plants that are going to do this. And the biggest example that you're going to see with it are trees. So in this picture, you can see that you have a tree growing up between the rock. And so what would have happened here is there was a small crack in the rock that a seed fell into. And then there was probably just enough dirt and nutrients in that little crack for that seed to grow. And as it grew, the tree got bigger and bigger and bigger until finally the tree started to crack the rock open or wedge the rock apart. And that's why we call it biological activity, because plants are living things. And I do have a couple more pictures of it. So you may be familiar with this if you've ever seen a tree that's a little bit too close to a sidewalk. As it grows, it can start to break the sidewalk apart. And then in this lower picture on the right-hand corner, you can see very easily that you had a tree that started to grow between the crack of a rock, and it just grew up and actually broke that rock apart. So the next type of weathering we have is called abrasion. Now, if you ever have an abrasion on your arm or your leg, then that typically means that you have some form of a cut that has occurred. Now, when you think of abrasion, I want you to think of sandpaper, okay? When abrasion is going on, you have something that's just like you're sanding down a material. And sandpaper is very rough, it's very grainy. So the main thing that causes abrasion is actually sand. It's not sandpaper, but it is sand that's typically caused from running water, waves, or wind. So I want you to think about this picture down here. You have a lake with some waves, and you can see these rocks or these pebbles are very, very smooth. And what's caused these rocks to become so smooth is those waves are picking up pieces of sand and it's throwing them on top of the rock, and when the wave goes back, it rubs it against the rock again. And so with each wave that's going back and forth across that rock, it's just like you're getting sandpaper going back and forth across the rock until that rock becomes very smooth. Now, that same thing can happen with wind. I don't know if you've ever been outside and wind blew dirt in your eyes, or if you've ever been on the beach and the wind started blowing the sand and it hit your legs and it actually started to burn your legs a little bit or sting your legs. That would be an example of abrasion. And yes, it's not going to, put holes in your legs from you just standing on the beach for a few minutes. But if you are a rock that's been standing there for decades, then eventually that sand continuously hitting against the rock will eventually weather or break it away, and it can cause it to become very smooth, or it could even create like holes within the rock. So that's your abrasion. Next, we're going to look at chemical weathering. So the 4 weathering that we just looked at, those are all examples of your physical or your mechanical weathering. So that was the frost wedging, biological activity, unloading, and then abrasion. With chemical weathering, you actually are going to change the rock's composition. So it's going to change into 1 or more new compounds. So this would be like if you were burning that piece of paper. It's chemically changed the composition. It is now something new. And we're really going to see this in 2 ways, and those ways are acid rain and rust. Now, another name for rust is oxidation. So everybody say oxidation. Oxidation is going to be the fancy word that they use for rust, and so it's something that you should probably become more familiar with, because when you start to hear oxidation, you need to instantly think rust. But we'll look at this in a little bit more detail. So next slide. Here are your agents of chemical weathering. When I say agents of chemical weathering, I'm simply referring to the 3 things that typically cause it. So water is going to be one of the biggest, most important, and main factors in something that causes your chemical weathering. Now, it also can cause mechanical weathering, but here we're just going to look at how it can cause your chemical. So when you have water vapor in the air, or even water that's in a lake or something, but let's look at water vapor for now, a gas form, that water vapor can mix with other gases in the atmosphere. And when it does that, it can cause our precipitation to actually come down as an acid. So think about all the carbon dioxide that we have in the air. And this is actually me explaining not only water, but the carbon dioxide. So that carbon dioxide gas can mix with the water vapor and create carbonic acid. And when it creates that carbonic acid, it's still in that gas form. When it precipitates down as a liquid, we now call that acid rain. We're going to look at acid rain a little bit more once we get to the environmental side of earth science, but most rain is acid rain. People tend to think acid rain is something if you go outside, it's just going to burn your skin off. No, a lot of acids think about apple juice. That's an acidic juice. So when you go outside and it's raining, it probably is a little bit acidic because we do have so much pollution in the air, but it's not going to burn holes in your skin, but over time, it can cause changes in your rocks. So that's how water vapor and carbon dioxide are going to be big agents in your chemical weathering. The other big agent is your oxygen. And the reason oxygen is a big agent of chemical weathering is because it can create that oxidation, which is rust. So when you have that oxygen mixing with iron in something, it can cause rust. And that's not only for chains on like a bicycle, but it can also be seen in actual rocks as well if they have that mineral. And these are just a couple pictures. So these top 2 pictures are examples. This is your acid rain. So if you've ever seen statues or maybe even gone to a grave and seen that you can't read the tombstone anymore because it just looks like parts of it have melted away, kind of like the statue's face, then that is because the acid rain slowly over time has weathered away parts of that rock. And so that's what you get here. When you look at this picture, the rock looks really weird. It almost looks like craters on a moon or something. But what happened here to make it look this way is you had the gases in the atmosphere that mixed with the water that was in that lake. And as those waves put the water onto that rock, it sat there. And so you have this acidic water that's just sitting on the rock. And over time, the more that happens, it's going to dissolve more and more layers of that rock away, leaving these little crater-like areas. Now, this one and this one as well, they're both really showing you an example of oxidation because you can see this rust that's left on the rock as well as the chain, that rusty color. But with these other ones, you can see these rocks these boulders have turned into a very curved surface. And so what's causing these rocks to be that way is when it rains down, you have this acidic water, again, that's going over the sides of the rock and down to the bottom. And when that happens, each time that water is dripping over the rock and surrounding the rock, it's just dissolving away a little portion at a time of the rock until it changes the shape of it completely. So what affects the rate of weathering? When we're looking at the rate of weathering, we're looking at how fast will it occur. So this is going to look at what's going to cause it to happen faster versus what's going to cause it to happen slower. So the first thing we're going to look at is your mineral composition. Now, remember, rocks are made up of minerals. You learned that in Unit 4. So depending on the kind of mineral within the rock is going to depend on how quickly it will weather and the type of weathering that will occur. If it is a rock that has a lot of iron in it, it's more likely to experience oxidation. If it is a rock that has a mineral in it that is very soluble, which means it can dissolve in water, then that rock is more likely to weather very quickly, especially if it's an area that has a lot of moisture within the air. And then you're going to look at surface area. Now, you need to write this down, but the more surface area, I'm just going to put SA for surface area, the more surface area, the faster the weathering. So faster weathering. That is a very big deal to know. So I want you to write that and put a star next to it. A beautiful star that I just drew. It means that it's very, very important. So the more surface area, the faster the rate of weathering. Okay. And this makes sense if you think about it. I don't know how many of you are cooks out there, but if you get a baked potato and you put that potato in an oven, it's going to take a long time for that potato to cook. But if you expose more of the surface or more of the area of that potato to the surface surrounding it, aka chopping the potato up into French fries or something, then that potato is going to cook much faster. Or say you have a mound of Play-Doh and it's just in a ball. Well, if you squish that, making it very thin and round, it's then going to have more of the area of the sphere that is now exposed to the surrounding. And so the more surface area, the more area exposed to the surface around it, therefore it is able to weather quicker because more of it is exposed to the elements outside. So more surface area or greater the surface area, the faster the weathering. And then the last thing that can affect the rate of your weathering is the climate. The specific climate that causes weathering to happen the fastest is hot, wet climates. So your warm, moist climates, like the tropical rainforest, is what's going to cause weathering to occur the fastest. So areas like your tropics are going to have a higher rate of weathering than areas such as the poles because it's much warmer, there's a lot more moisture. We all know that heat can cause chemical reactions to actually speed up because molecules are moving faster, and that's actually what you see going on within the weathering process. And then also the more moisture. We already talked about how water is one of the main agents that weathering occurs through. And so you're going to see it more that way as well. So let's go on. Actually, that's it for our notes. So that is all for weathering. So just a quick recap. We talked about the two kinds of weathering. Well, first of all, we said that weathering is the breaking of rocks. Okay? The breaking down of rocks. There's two kinds. You have chemical and then you have mechanical. And I'm not writing all of this down. But you have mechanical and you have chemical. Chemical changes the compounds. Mechanical equals no change in the composition or the compounds of it. Mechanical has 4 ways. So you have the frost wedging, you have biological activity, you have unloading, and you have abrasion. With chemical, you have 2 main ways. You have your acid rain, and you have oxidation, which is going to be the rust. Then with the chemical weathering, we talked about the agents of chemical weathering, so your water vapor, your carbon dioxide, and your oxygen. And then we talked about things that change the rate of weathering. So make sure you're familiar with all those things. And then if you have a question, just let me know, email me. And as always, if you ever need to set up a separate Zoom meeting, then we can always set that up. And that's it for today's notes.